Okay, so if you are quarantined or absent, we are going to practice doing some charged atom problems. So how would we do that? So what we're going to do first is draw an atom. So I'm going to pick something small, such as boron, which only has 5 protons. So boron, being the fifth element, is going to have 5 protons. 2, 3, 4, and 5. Now we're going to say that this boron has a mass of 9. So I'm going to add in 4 neutrons. Okay, so there's my nucleus of my boron. I have 5 protons, which makes it boron, and I have 4 neutrons, which makes it boron with a total mass of 9, because 4 plus 5 equals 9. Now, how do you get an atom with a charge? So if you charge an atom, it means it has an imbalance of protons and electrons. So for example, if I have 5 protons, I'm going to write out, I'm going to change my color. I'm going to write out my tally of protons over here. Okay, so if I have 5 protons, I have 5 pluses. So my total charge right now is 5 plus. Well, if I add an equal number of negative electrons, that is going to neutralize my charge. So if I have 5 negatives, that means that they all cancel each other out and I have no net charge. Well, what happens in chemistry is atoms get charges for one reason or another, and that comes from an imbalance of electrons to the protons. Now, to charge this boron, I am not going to add a proton, because if I add a proton, it's not a boron atom anymore. It then becomes carbon, because then it would have 6 protons and not 5. So I don't want to do that. What I'm going to do is add or take away electrons only. So let's practice. If I add in an extra electron for a total of 1, 2, 3, 4, 5, 6 electrons, then I'm going to have 6 negatives compared to 5 positives. So when I cancel each one out, which one am I left over with? 1 negative. So my charge is 1 minus. So let's do another one. What happens if I have 2 negatives? That gives me 2 negatives left over, so then it becomes 2 minus. Now let's try a couple other charges. Let's say that in my atom model, I end up actually, let's say we lose an electron. Okay, so now I only have 4. So I cross out what I have, and I'm left over with 1 positive. Now I didn't add a proton or take away a proton, I just messed with the electrons. So the imbalance of protons and electrons gives me 1 positive more than I have for negatives, so that my charge will be 1 plus. If I were to lose another electron, well, that would mean that I would get rid of that 4th electron and only have 3. So now I have 2 positives more than my negatives, and so that means that my charge is 2 plus. So that's how you do charges. So the simplest way to do it is you tally your protons that you have in your nucleus in a line, and then you total up your electrons that you have. And if you're trying to get a charge, then you need to, let's do this the other way. So I'm going to change my atom. Let's say we have carbon, so I add a 6th proton, and we're going to give it a mass of 10. So carbon with a mass of 10 is my new isotope. So what do I do here? Let's say I want to get a charge of -4 for carbon 10. Okay? So if I want to get a charge of -4, that means that my electron total has to be 4 more than protons. So right now I have 4 electrons. So I'm going to go ahead and write those in. So right now my charge is 2 plus because I have 2 more positives than I do negatives. And my goal is to get to a charge of 4 minus. So what I do is I add another one. Now my charge is 1 plus. Add another one. Now I'm a charge of 0. And then I add another one. Now I have 1 more negative than I do positive. So now my charge is -1. I keep going. -2. -3. And -4. So how many electrons do I need to have a charge of -4 for a carbon 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You need 10 electrons. So email me if you have any questions, and I hope that was helpful. But that's how you do charges for atoms. It's just an imbalance of protons to electrons.